So we saw in our previous video that this adapter plate was not particularly well made, and I wanted it slightly thinner anyway because of the engagement of the clutch splines. So you can see I have a lovely shiny new piece of plate being delivered, and I'm just sorting things out for making and getting the holes accurately positioned. So I have the alignment tool made up that will allow me to line the bell housing accurately up with the centre line, but I then want to align the bell housing to the adapter plate and the adapter plate to the engine. And what you can see here is a little thing I've made up. Be a little bit careful with it. But there are the two engine dowels. They now have internal M12 threads, because I discovered that particularly on this one, had almost none of its M10 thread left in the block, and I pulled both of them out to helicoil the block back to standard. And these are 15mm OD dowels, or hollow dowels, or whatever you want to call them, and I machined up quickly a couple of bushings which were drilled and reamed M15, and then I simply placed them on the block and used some super glue to attach a piece of bar stock to them, which I could then put in the milling machine and, using a centering probe, measure the centre to centre distance, or centre up on each bush and then measure the centre to centre distance to confirm the measurement I'd got with my large set of calipers, which were kind of over their proper operating range, with the vernier off scale, so that I could only look at the major markings, and it did appear to be dead on, from memory, 323mm. But in any case, whatever measurement I got, I've confirmed that it's good and accurate, and I've also taken measurements from the outside of the dowels to the outside of the pilot diameter on the end of the crank, and obviously then subtracted half the diameter of the boss on the crank and half the diameter of the dowel to get a distance from each of those dowels to the crank centre line, and put that into CAD, and I now know the position of the centre line of the crank to within a degree. It's not going to be perfect, because the errors all add up, and without setting the whole crankcase up on a bed of a milling machine and properly dialing into all the locations. But because I have this other method of alignment, it doesn't really matter. I just need the crank centre line within a millimetre or two, which will allow me to know the centre of the large circular cutout I need to clear the flywheel. The plan is to use the existing plate to get the approximate position of the two dowel holes. Line the plate up with those holes in line with the x-axis to drill and bore those to the 15mm. The 15mm dimension doesn't go all the way through. And then to mark off the centre position, and then use a rotary table and to trepan out the middle of the flywheel clearance. I don't think this existing circle is very accurately centred at all. I mean, it doesn't really need to be, it's just clearing the flywheel, but I can do a better job than that by taking measurements. And then the final job will be to do the alignment with my alignment tool, get the bell housing positioned, and the bell housing had its own dowel positions, one of which is going to go away because the bell housing needs to be clearanced for the nose of the starter motor. So we'll pick another hole location and convert that into a location dowel as well. So I can get by all the holes in the bell housing are of course bolt clearance sizes, but by taking one out to the next reamer size, I can then get an accurate position to transfer onto the adapter plate and then use that to create an accurate dowel position, and we'll have it all nicely aligned so that should I need to separate and bolt back together in future, I don't need to be doing tricks like rotating the gearbox input shaft whilst wiggling the bell housing until it all runs as quietly as possible, which is the approach that people use when they don't have the accurate positions. But it becomes a pain if you ever have to disturb it to service a clutch, service a gearbox, whatever. So this is take 2 of getting this set up right. So I have the old adapter plate positioned on the new piece of plate, drawn around the profile, marked the position of the 2 dowel holes, and then I was checking I'd done everything correctly and realised I had the plate the wrong way over, so that the counter bores for the dowels were on the wrong side. So I cleaned the plate off, bit of isopropyl, took off the Sharpie marker and remarked. So we now have the 2 important holes are marked. I did also transfer punch them, and the circle in the middle is marking the crank center line. I'm going to be using the dimensions I gained from the CAD to get a center mark there, which will then be used to center up this plate to trepan out the large diameter flywheel clearance. And we've got a piece of 19mm or 18mm, haven't checked, MDF underneath so that I can drill straight through. I like using MDF for this sort of thing. It's got a very consistent thickness, and it's relatively cheap. So I'm just going to get this all set up and clamped down and aligned. So I've got a bit of tension on this clamp, bit of cardboard in between just so I don't mar up the plate. Hand tension on this side, and I have visually lined up on that little mark that I made with the transfer punch. So we'll drive down to the other end and see how good my eyeball alignment was just setting the plate up initially. I think I'll declare that my victory for the day. That's pretty good. Well, maybe 3-4mm off. So I'll tap that in, and these positions are not that critical. The distance between these holes is the one that's important. Their position on the plate only needs to be good enough that the profile I need to cut comes within the stock available. So in fact it's probably good enough already, but it will take me no effort at all to get that pretty much spot on visually, and then I will be able to drill these holes using the DRO for the spacing, and then to do the counter bores. So I've got the two holes with their counter bores done, and using the CAD software came up with the position for the crank centre line. Put a tiny little divot in there for that, and there's a very faint line which you might just pick up with a set of dividers for the flywheel cutout. And I've done a sanity check with the original plate that is in the right position. So the next job will be to set up the rotary table and come up with a way of attaching this plate so that I can trepan that centre circle out, and it's approximately 300mm diameter. So I'm going to have a think about this, possibly a double-sided tape or a super glue type job, or I think I might be able to bolt the piece of MDF down with some countersunk screws and then clamp the plate to it. Okay, so this is the solution that I've come up with as just being something quick and simple. I have made some wooden T-nuts on the bandsaw, and you can see I've got the spoil board I was using before with 3 screws that are countersunk below the surface. On the other side I'd marked out the pattern from the rotary table just to get some positions, and everything's got a little bit of wiggle room. The reason this pattern is off centre is because these are the holes where I drilled through the actual plate, and I just put 2 screws through to clamp it together. I don't think it really matters. It should work. So this is all going to get, I'm going to extend these screws enough to use them as transverse screws, mark the T-nuts and pre-drill them so that they don't split, and we'll get this clamped on. We'll then get the actual aluminium plate bolted down to this, and probably some additional clamps around the edges, and then I should be able to trepan out that flywheel clearance hole. I'm in no particular hurry, so I can take light cuts, and I think this should all be adequate to get the job done. I've got the MDF secured down into the wooden T-nuts, and it actually feels pretty secure. So the next thing will be to screw down the aluminium plate on top and get it nudged into alignment with the spindle. Well, here we go. I've only had to give it a couple of light taps. The shininess and shadows make it a little bit difficult to see, but as previously mentioned, the alignment isn't all that critical because it's just clearance for the flywheel. But it's looking pretty good. So I'll get those 2 screws tightened down and some probably clamped from the edges as well, and then we'll move this over a suitable distance to get the diameter I need, and give it a go. Okay, let's see how this goes. Just going to do a couple of millimeters depth to start with. just going to have a little pause there. The Mini Cool's creating a little bit more of a an aerosol that I'm happy with without the doors open. Okay, well, it appears we had a bunch of problems with me, the machining and the camera. So I didn't realise I hadn't turned the camera back on. I had a problem with the lubricant bottle. The pickup came out, the cutter ran dry, I snapped a cutter. Then I knocked the reservoir on the floor and had to clean everything up. I had to move the camera out the way. Then the camera decided it didn't like the heat and it wasn't recording, corrupted one of the files. But I realised finally, having been ploughing very happily through this, I'm down to about 14.7 millimeters deep in the 15mm plate. 1mm cuts were doing really well, taking a pass, vacuuming out the chips, which were mostly staying in the back of the cut, not in front of the cutter. No problems with recutting chips. It's going really well, and this is the point I would have paused and said that what I'm going to do next is mark some positions for me to leave some tabs, because we've got another, well, if I go down another 0.5mm I should have broken well through into the spoil board, and I don't want it shifting around, so I'm just going to leave some tabs in place, and I can do the final machining with I can break the tabs by keeping a hand on the plate to keep things in place, but I just want to make sure everything's good between then. If you're hearing wind noise, it's because I've got the workshop doors and there's a pretty steady breeze blowing through. I've been wearing a mask anyway, just to be on the safe side, and yeah, so I'm just going to make some marks and we'll get to it. So I'm back to the first tab I cut, and at this point I'm going to use hand pressure to hold everything in place, just to cut through the tabs. And we should be free. And that doesn't look like too bad a finish either. So I'll decide at this moment whether I want to take a clean up cut all the way around, but that worked very nicely. Well, the proof of the pudding is in the eating, and it fits, and it's a really nice fit over the dowels, and I'm really happy with how that turned out. I did in the end decide to give it a quick skim on the ID, but I didn't film that. That was after I'd moved the camera out the way and then changed my mind. But yeah, really happy with that. So the next job will be to use transfer screws to get all the other positions marked, and then to use the alignment tool I made up and one of the bell housings. Probably not that one. It'll probably be the one that's on the temporary gearbox mock-up, because that is the type I will be using, even if not the actual one. And we will get the holes for the gearbox side drilled as well, and look at getting the location dowels for that sorted out. But this was a fairly large job. I wanted to get that out of the way, and I'm really pleased with how that's gone.